Hello everyone, I am Dr. Miracle Shrestha and you are watching Applied Chemistry, and today we are going to talk about properties of xenon compound. This is taken from the pblock element which carry lots of weightage this year. In 2021, in your board examination, you will definitely get 2-mark question from this particular topic, which we are going to discuss today only in this lecture. Okay, so please take care that you are learning all the reactions involved. Although I will make sure that you don't need to learn it, you will understand it and you can never forget. Okay, so let us start the topic. Okay, so first thing is we are going to talk here xenon compound. The one thing which we already know that xenon belongs to 18th group, and just because 18 group elements are having outermost shell configuration ns2np6. ns2np6 means outermost shell is completed, their octet is completed, having 8 electron in the outermost shell. So just like other element, helium, neon, argon, this xenon is also belong to the group which do not react, hence this also has tendency not to react क्योंकि ये भी octet completed है तो ये भी react नहीं करेगी. Now how is it possible for us to make the xenon compound, and how did we came to know that xenon can make compound? Because general tendency of the elements belonging to the 18 group is that they don't form compounds, isn't it? Now let us talk about how we came to know that xenon can also make compound. The first thing is that in 1962, this is the year when we came to know that xenon can also make compound, although it belongs to the 18th group. So what happened this year? There was a scientist called Neil Bartlett. And he was doing an experiment in which he observed that oxygen ionization enthalpy of molecular oxygen means if I want to remove an electron from the oxygen, this ionization energy, first ionization enthalpy of the oxygen molecule is 1175 kilojoules per mole. Okay, during the making of a compound, he observed this thing. कौन सा compound बना रहा था? He was actually reacting this oxygen with the platinum hexafluoride PtF6, and what is formed? The compound formed was O2 PtF6, and this compound is of this kind where this oxygen is removing in one electron and here it is getting minus. So this type of compound was formed, and during this preparation he observed ionization enthalpy, first ionization means the electron released, first electron when it was released, the energy required was 1175 kilojoule per mole, and then he compared his this particular energy required for the removal of electron from the oxygen. He compared this energy with the ionization enthalpy of the xenon, which is almost near to this energy required, and it is what? First ionization enthalpy of xenon is 1170 kilojoules per mole. So you can understand that both the elements are having almost equal enthalpy required for the removal of first electron. Okay. Now he came to know that if their energy required to remove the one electron from their outermost shell is almost equal, तो how is it not possible? अगर ऑक्सीजन के कंपाउंड बन सकते हैं तो फिर xenon के क्यों नहीं बन सकते? Then this idea came into the mind of all the scientists that yes, this could be possible, and then they started making the compound of xenon. Later on, they've made many compounds of the xenon, and most of the time just because the xenon is not having tendency to make the compounds, general tendency तो नहीं है just because इसका octet completed है, but हाँ, in the harsh circumstances, and one important thing, fluorine and oxygen के साथ, these two elements are having very high electronegativity. क्योंकि ये बहुत ज़्यादा electronegative है, they can insist the xenon to lose the electron. So with the fluorine and oxygen, xenon can make compound, and these are most of the time xenon oxides, xenon fluorides, and xenon oxofluorides. So 3 types of compound we are going to discuss in this particular video. So let us start one by one. What type of compounds are being formed by the xenon, and we will be discussing the property of the compound. Okay. Second important thing here is that xenon के compounds मिलते हैं, but no compounds of helium, neon and argon are found till date. इनके कोई भी कंपाउंड नहीं मिले, तो दे डोंट फॉर्म एनी कंपाउंड. बट रेडॉन का एक कंपाउंड इज फॉर्म RnF2. रेडॉन फ्लोराइड इज ऑब्जर्व्ड एंड krypton fluoride is observed. So out of the like these two compounds are also there which are observed from the noble gases, but the rest of the elements like helium, neon and argon, they don't form compound. Xenon makes the compound, but it makes the compound with the fluorine and oxygen. The reason behind, क्योंकि fluorine and oxygen are very electronegative in nature. I hope इतना कम समझ में आ गया. Now let's talk about the compound, the properties of these compounds. So let's start with it. These all compounds are colorless, crystalline, and they can sublime at 25 degrees Celsius. कितने टेम्परेचर पर? 25 degrees Celsius पर these compounds sublime. So these are not very much stable. Second thing is, one by one we'll be taking the different properties of this compound. First of all, I am taking as a fluorinating agent how they work. Fluorinating agents. So xenon compounds as fluorinating agent. So what do you mean by fluorinating agent? Fluorinating agents are those compounds which fluorinate others. Means the compounds which add the fluorine to the other compounds are called fluorinating agents. तो जो compounds दूसरे compounds में fluorine को add करते हैं, they are called fluorinating agent. So let's see the example where xenon के fluorides are working as a fluorinating agent. So I am taking XiF2 and I am reacting it with hydrogen. So here we have hydrogen and here it is XiF2. Obviously the xenon is not having the tendency to react with anything else. तो hydrogen को देखते ही this xenon is going to give this its fluorine to this hydrogen. भाई तुम रखो इस hydrogen को fluorine को. I am not interested in making the compounds क्योंकि इसका general tendency is not to make the compounds. So what will happen? The xenon will become free and hydrogen will be fluorinated. So HF will be formed. So this is the reaction going to take place. Okay. Same way, xenon XeF4 can also fluorinate hydrogen Xe plus HF. Reaction you will be balancing. Next, in the same way, if I am using XeF6 and then I am going to react it with the hydrogen, this can work as a fluorinating agent also. So Xe plus HF. You have to just balance the reaction, otherwise the reaction is of same kind. Xenon, fluoride, F2, F4, F6, hexa, di or tetra, all the fluorides of xenon are going to fluorinate hydrogen. Okay. Next reaction is where you are going to fluorinate it. It's a different reaction, that is XiF4 I am taking and I am going to react it with SF4. Sulfur tetrafluoride. We all know that the covalency of the sulfur can be extended to the +6. Sulfur can show +6 oxidation state. So this is going to fluorinate sulfur SF4. So what will happen here? So xenon will remain free and sulfur tetrafluoride will convert into sulfur hexafluoride. So SeF6 will be formed, SF6 will be formed and xenon will remain free. Same kind of reaction, मतलब xenon free हो जाएगी और दूसरे को अपना fluorine पकड़ा देगी. Same one more reaction is there the same way that I am taking here xenon tetrafluoride. Then I am going to react it with platinum. So what will happen? Platinum will be fluorinated and xenon will remain free. Platinum will be fluorinated and xenon will be free. So this way you can see here, this is working as a fluorinating agent. Fluorinating agents which fluorinate others, which add fluorine to the others are called fluorinating agent. Now let us talk about next type of reactions where xenon के compounds are going to work as a fluoride donors and sometimes they work as a fluoride acceptor. Some name xenon fluoride, difluoride and xenon tetrafluoride. These xenon fluorides are working as a fluoride donor, that is XeF2. Let's see, let's understand this concept by taking the reaction. I am taking here xenon difluoride and I am going to react it with PA5. Now what will happen? This xenon fluoride is going to give one fluoride ion to this PF5, and when it will do so, it will convert itself into XEF. One fluoride ion is given, so positive charge will appear on the xenon fluoride, and when this PF5 will gain one fluoride ion, it will convert into PF6. So there is a salt formed in this particular reaction. So in this particular reaction, this xenon fluoride is going to work as a fluoride donor, and minus donors are called bases. So this is working as a Lewis base here. On the same way, we can take the example of XEF4 here. This is also going to work as a fluoride donors. So what we are taking here example is SbF5. So let's see if it will donate its one fluoride ion, क्या होगा? Xenon F4 है. I'm taking it, giving it one fluoride to this. So positive charge will appear on it, and SbF6 will be formed, and one fluoride का minus charge will appear. So this is one of the salt here. In the same way, xenon hexafluoride can also work as a donor, that is XeF6. So look at the reaction, PTF5, and it is going to donate its one electron, one fluoride ion, to XeF5 will remain, positive charge will appear, and PTF5 will gain one fluoride and it will turn into PTF6, and this is how it is working as a donor of fluoride ion. But this XeF6 is special, which gives a special reaction where sometimes it takes the fluoride ion also. So I am going to take this reaction, fluoride ion acceptor, with the reaction where it is reacting with the salt of first group elements. When it works as fluoride ion acceptor, if you are taking first group element के fluoride, these fluoride can be given to the xenon hexafluoride. मतलब with this kind of compound, this xenon fluoride can accept the electron as well. It donates. It's a general trend for all the fluorides. लेकिन यहाँ पे in this case it can get also. So I am writing down the reaction where it is reacting with MF, where this M is a metal of the first group, and then only it will work like this only, na. So this is MF के साथ it is going to react with XeF6, and what will happen here? This M metal is going to give its fluoride ion to the xenon. तो क्या होगा? M plus will remain here because it has donated. यहाँ पे there is no charge क्योंकि sodium, suppose it is sodium का fluoride, so it is sodium fluoride. So sodium metal will remain, which will make the positive charge, and this XeF6 will turn into XeF7, and one minus charge will appear on it. So this kind of salt will be formed. So this particular reaction, it is working as a fluoride ion acceptor. Rest of the xenon in other reaction are working as a fluoride ion donor. Is it clear? So this way xenon fluorides react as a donor sometimes and as a acceptor in very few cases. The cases where the fluorides of the first group element are taken, then only it will work as an acceptor. In the rest of the reaction, it is working as a donor of fluoride ion. Very important reaction. This reaction is one of the very important reaction. This also comes sometimes, but this you have to take care of, that they can give you the metal, like they can give you like what will happen when sodium fluoride react with XeF6. So what will be the answer? Sodium XeF7. So this will be your compound. Now let us talk about last reaction given by the xenon fluorides, that is hydrolysis of xenon fluorides. In this particular reaction, hydrolysis reaction, will be considering two type of hydrolysis. First is complete hydrolysis, second is incomplete hydrolysis, which is also called partial hydrolysis. First thing is, what is hydrolysis? Breaking in the presence of water is called hydrolysis. So one by one we will be reacting all type of fluorides with water, and we will see the product. If it is broken, that product is broken, like xenon ke fluorides are broken completely, they will be free either as xenon or they will form the xenon oxide in case of complete hydrolysis. Otherwise they will form xenon oxofluoride. That you have to take care. So in the first case we will be completely hydrolyzing them. तो complete hydrolysis पहले पढ़ते हैं. In the complete hydrolysis of xenon, I am taking XeF2 first, and I am going to react it with the water. Now what is going to happen here? Just because the xenon fluoride is not that stable, it will break down in the presence of water, and this fluorine will love to go with the hydrogen rather than going with the oxygen. तो आपको तीन प्रोडक्ट मिलेंगे. First is xenon, which is now free from the fluorine. Second is HF, and third one is this oxygen, which is getting free. Okay, so this is the hydrolysis, complete hydrolysis of xenon difluoride. Okay, next reaction is xenon tetrafluoride. So let's see what happens when xenon tetrafluoride will be formed. I would like you to write down the reaction in the same way as I am writing it on the blackboard, on the board. The reason behind is कि most of the time students forget कि कैसे कौन सी reaction में क्या products होते हैं. That is why it is I am suggesting you to write down the things in sequence so that you will remember कि XeF2 के breakdown में what were the product, XeF4 के product में breakdown में what were the product, and so on. So just write down the things in sequence, and whatever the instructions I am giving you, try to follow that. So what I am doing here is XeF4 and H2O, and the final product I am writing down like same products first. You just write down Xe plus, I am leaving some space here, you just also leave in the same way, HF plus O2. तो ये तो बनेगा ही, साथ में one more product is formed, and that is what? XeO3. This is one extra product formed in this particular case, that is XeF4. When it is completely hydrolyzed, it forms xenon, HF, xenon oxide, and oxygen. So this way, these are the product on the hydrolysis of xenon fluoride, tetrafluoride. ठीक है? In the same way, if I go for XeF6, let's see the product, complete hydrolysis product of XeF6. As I told you, write down the reaction in the same way as I am telling you, because most of the time students get confused. So these two will be the final product. I wanted you to see this reaction very carefully. The final product will be XeO3 and HF. तो अगर आप इनको ऊपर नीचे कर देंगे, if you are trying to do it in a like a random manner, तो you will not be able to, you have to just understand, या you have to just mug up the reaction कि किसमें क्या बना था. Otherwise if you are doing it in the sequence, I am telling you xenon, HF and O2, ये तो हमें याद हो जाएगा, just because we know this thing कि xenon will be free, HF will be formed, because oxygen is not having that good affinity towards the fluorine, क्योंकि oxygen and fluorine both are electronegative in nature, isn't it? Same way I am telling you here कि this three product will be formed common, and this xenon oxide is formed. This xenon oxide is very special compound क्योंकि ये xenon oxide is explosive. क्या है ये? Explosive. So ABC kind of compound में भी आ सकता है, but when this fluoride is hydrolyzed, an explosive product is formed along with HF. So this is the reaction. मतलब आप XeF6 को hydrolyze कर रहे हैं. So these three reactions are the hydrolysis, complete hydrolysis reaction of the xenon, XeF2, XeF4 and XeF6. Let us talk about the incomplete hydrolysis, which is also called partial hydrolysis. Partial hydrolysis में you will not be getting this xenon free, you will get xenon oxyfluoride. तो आपको xenon की oxygen और fluorine के product मिलेंगे. So let's see what happens when xenon fluorides are hydrolyzed partially. So the first reaction is XeF4 से I am starting क्योंकि आपके NCERT में it is given only. Okay, XeF4 when it is hydrolyzed partially, as I told you, completely xenon will not become free. तो क्या बनेगा? Xenon oxyfluoride. So you will get XeOF2 as a product, and what will left out? HF. So these will be the product XeOF of F2. That is xenon oxyfluoride will be formed. Same way, XeF6 को if I hydrolyze. Okay. The first reaction is that XeF6 will hydrolyze partially to give you XeOF4 plus HF. Can you see there? 2 fluorine are being increased here and 2 fluorine are being increased here. No need to learn the reaction. Learn नहीं करना है आपको. Just add it. F4 तो यहाँ F2 था. Reaction को अगर आप balance करेंगे तो you will get it here, isn't it? तो what will be the product of XeF6? 2 fluorine are extra here. 2 फ्लोरीन आप यहाँ ऐड कर दीजिए. So this is a simple reaction. Just write it in sequence so that things become easier for you, and you will not need to even revise the reactions. What easier? Next is, if I am doing this XCF6 in the presence of 1:2 ratio of water, then what will happen? Then this XeOF4 will not be the product. XeO2F2 will be the product then, and HF will be formed. Okay, or you can write down this reaction. Actually, these two reactions actually are continuously taking place. If we add water, more and more water to it, like XCF6 plus H2O, क्या होगा? XeOF4, just like here. I made it here. XeOF4 and HF will be formed. यही बना था. अब ये XeOF4, this XeOF4 is actually what is happening here. This XeOF4 in the presence of more water is going to convert into XeO2F2, and what else will be formed? HF. So ultimately you can write down this reaction as this, okay, or you can write down this reaction as this. So you will be getting two products here, XeOF4 and XeO2F2. Okay, you just follow the NCERT. In NCERT it is given like this. So these all are the reactions of xenon fluoride, xenon compounds. You do remember these reactions, hydrolysis reactions, you will definitely get in your exams. Apart from that, the reaction in which it was working as a fluoride ion acceptor, these were very important. So please learn these reactions. Another thing which you are going to get in your exam related with group 18 is structure of xenon compound. Structure of xenon compound, I have already made video on this. So if you want to see this video to understand that concept, go through this link. Thank you very much.